Greetings everyone. Today I am here to talk about a revolutionary concept that has the potential to transform the way we vote. We are living in an era where technology has disrupted every aspect of our lives, and now it's time for it to revolutionize the voting system too.
The team members for this project are Kartik, Singhvi, Khush Shah, Ankit Lochan and Kirtan Makwana.
But why do we need a new voting system, you may ask? The answer is simple. The traditional voting system is plagued with issues such as voter fraud, vote manipulation, and lack of transparency. These issues have led to a growing distrust in the voting process and have raised concerns about the legitimacy of election results. Our decentralized voting system using Ethereum smart contract aims to address these issues and provide a secure and transparent voting platform for everyone. Now let's look at the traditional voting system. Typically, it involves several steps. First, eligible voters must register to vote and provide identification to confirm their eligibility. On election day, voters visit their designated polling place and cast their vote using a paper ballot or electronic voting machine. The votes are then collected and counted by poll workers, and the results are transmitted to the Central Election Authority. Finally, the election authority tallies the votes and declares the winner. While this process has been used for decades, it is not without its flaws and has led to concerns about the integrity of the election results. Now let's take a walkthrough over the several benefits of this new voting system. Number 1. Transparency and immutability. Integrity of the process is ensured by the fact that once a vote has been cast, it cannot be altered or tampered with. Number 2. Accessibility. It enables voters to cast their votes remotely, eliminating the need for physical polling stations and providing a secure and transparent platform that is accessible to anyone with an internet connection. Number 3. Efficiency. It eliminates intermediaries, reducing the risk of fraud and allowing for real-time vote counting. Last but not the least, trust. It has increased trust compared to traditional voting system by providing a secure and transparent platform that is resistant to manipulation and allows for independent verification of the election results. Now let's look at a use case where the residents of a colony seek to democratically elect their secretary. At first we'll look at the traditional way of conducting vote. To establish a voting location so citizens can exercise their right to vote. This system can be costly to set up and run, open to manipulation and subject to fraud. Now we look at the decentralized way of conducting vote. We create a voting smart contract that specifies the rules of the vote, the people who are eligible to vote, the time frame for voting and the voting possibilities. Voting may be done safely and transparently using the smart contract using a web interface or a mobile app by residents who are entitled to vote. The smart contract can make sure that each voter can only cast one vote and that only those who are qualified to vote may do so. The votes may be counted and recorded on the Ethereum blockchain when the voting session is over. Because the blockchain is immutable, it prevents outcomes from being altered, and because the system is transparent, anybody can check the results to make sure that they are accurate and fair. The technologies used for this voting system are Solidity, React.js, Truffle Framework, Web3.js library, and Ganache, which is used for testing. Now you may wonder how the system works. Registration. People must first register to participate in the vote by making an account on the voting application. To avoid repeated registrations or illegal votes, this procedure would require confirming their identity. Second is casting votes. After they have enrolled, individuals may cast their ballots by using the voting application to send a transaction to the blockchain network. The network will verify the transaction and add details on the user's vote. Third is the process of counting votes. The blockchain network employs smart contracts to tally the results once the voting session is over to count the votes. The outcomes are then made accessible to the general public for viewing. Last but not the least is the audit trail. The blockchain records the voting transactions Thus, there is a full audit trail of the voting process that can be used to confirm the accuracy of the results. Now it's the time we all have been waiting for. We would like to give you a glimpse of how our voting decentralized system using Ethereum smart contract works. In the next few minutes, we will be showing you a demo of our platform in action. In this voting system, there are three types of users. First is the organizer, who is the only one with the right to create a candidate and a voter, but doesn't have the right to vote. Second is the candidate. Candidate is a person who is contesting for the election. Third is the voter, who has the right to vote. Candidate and the voter cannot create a candidate or a voter. This is my voter's account. Let's try creating a candidate. Now I'll enter my name, age, and a random address. If I submit it, it will throw an error stating that it's not a valid address. So I'll copy a valid address from using Ganache. Now you might wonder, what is Ganache? Ganache is a personal blockchain for Ethereum development that allows you developers to test and deploy smart contracts locally. In a voting decentralized system, Ganache can be used to simulate the Ethereum network and deploy the smart contract, enabling testing and debugging before deployment to the actual Ethereum network. If I press submit, now MetaMask notification appears. Now this address is sent to MetaMask, which will generate a transaction ID. Now I'll click on confirm. As you can see, it will throw an error stating that only the organizer can create a candidate. The account ending with DA is a voter account, and the account ending with 2143 is the organizer account. Now since this is an organizer account, it will let me create a candidate. See, the candidate is created successfully. As you can see, there are 4 candidates instead of 3. A new candidate, Khush, is created. Now using my organizer account, I'll try to cast a vote. It throws an error stating that I don't have the right to vote. Now in order to vote, I have to create a voter. Now I'm switching back to my voter account, the one ending with DA. Now I'm entering a name, age, and the address which we obtained from Ganache. If you press submit, it will throw an error stating that only the organizer can create a voter. Now I'll switch back to the organizer account. And the voter will be created successfully. If I go back to the home page, as you can see, the number of voters is 1. Now I'll try casting a vote. I'm switching back to the voter account. And if I cast a vote for Khush and click on confirm, the vote has been successfully casted. And if I refresh the page, you can see the number of votes for Khush is 1 instead of 0. It has been updated. Now let's check the winner. As you can see, Khush is the winner. He won the election by 1 vote. Now let's take a walkthrough over the backend of the system.
Hello, my name is Kartik and I'm going to show you the backend of one of our pages, create candidate for our SC402 project, Cryptography. So the create candidate pages which we made using React.js, we will input the name, we'll input the age, right? And we will input the address from Ganache. Right, Ganache is basically, it will create a node of a candidate or a voter or organizer with following data: the address, the name, and the age. And if it is successfully run, then it will join with the other local Ethereum network, right? Network which is there in our which is there in a Ganache, right? So what will happen when it presses submit button? It will go to the Web3 JS library, Web3 JS library, which is a functions, which are the functions of which have functions, right? Set of functions. So in this create candidate, it will take the parameters, then it will connect the wallet, right? It will connect the wallet. It establishes it establishes a connection with MetaMask, right? So basically, in MetaMask, what it does is that in MetaMask, the user is prompt to review and confirm the transaction detail. And once the user approves it, MetaMask signs the transaction with the user's private key and generates a transaction ID, right? So you generate a transaction ID. Then an instance is called, right? Now an instance is called. So what is an instance basically? Instance refers to instance of the deployed smart contract on the blockchain network. So when a smart contract is deployed, it is assigned a unique address on the network, and an instance of the contract can be created to interact with the deployed contract, right? So it will deploy a contract, right, on the blockchain network. So now the send function is called, right? The send function is called, and the transaction ID which was created using the MetaMask, it will be sent to the Ganache where the smart contract is deployed, right? So this is the smart contract for the create candidate, right? Create candidate. So this is the set of instruction which will be followed, right? So in this, let's take an example that this is an organizer's ID, right? Organizer or an admin's ID, right? So in the smart contract, we have written that only the organizer can create a candidate or a voter. Rest, no one can do so, right? Only an organizer. So if it's an organizer's ID, right, then the transaction ID. So the address would also be of an organizer, right? So it will be validated, right? And it will return to the Web3.js libraries that candidate created successfully, right? Candidate created successfully, and it will show in the front end, right? It will be shown in the front end. So basically, this is the more or less the backend. So now what will happen is that the Ganache will receive the transaction and it will validate, right? So the transaction, if the transaction is valid, as it is valid here because it's an organization's address, so what will happen is that the Ganache will add the transaction to a pool and broadcast it to other nodes in the network. It add in the transaction pool, right? So if there are, let's say, two candidates in the network, then it will also add a third, right? And this will be added by the miners, right? The transaction will be added by the miners who will verify it, and it will add to the next block in the blockchain. Once the
While our decentralized voting system using Ethereum smart contract has several advantages over traditional voting system, it is important to note that it also has its limitations. First is technical complexity. Decentralized voting system can be technically challenging to create and operate, requiring substantial skill. Given its complexity, the voting process's security and accuracy may be jeopardized by mistakes or flaws in the system. Second is limited accessibility. With decentralized voting systems, taking part in the voting process often requires specific software or hardware. This criterion could make it harder for some people or groups to participate or be accessible, including those who lack the necessary resources or technological know-how. Third is lack of anonymity. Certain decentralized voting methods might not completely guarantee anonymity, which can discourage voters from taking part out of fear of reprisal or retaliation. We would like to acknowledge the various resources that we have used to design the decentralized voting system.
We would like to thank Professor Manish Kumar Gupta for presenting us with this opportunity.